Great, let's get to it then. So, hey guys, thanks for coming. So the plan of this is the first series of workshops that we've undertaken on Bubble Protocol. This initial series is mainly about an introduction to the protocol and to the ecosystem around it, the tool sets. We're planning to run 4 workshops, and over the course of those 4, we're aiming to build a private shared file vault as a decentralized application. And it'll look something like what's shown on the screen. That's just a user interface design. And it will allow all members of the vault to share files and also to message between each other. So there'll be like a group chat and there will be a shared file area. So this is what the workshop plans look like. This is workshop 1. We're planning to build throughout these workshops. So we're going to start with a command line version of the Vault, which will introduce the Bubble Tools command line interface. As part of this, we will write the smart contract that controls the bubble. We'll create the bubble. We'll have a play around with reading and writing, changing access permissions, and just sort of having a bit of a play. And then finally, we'll delete the bubble, which will delete all the data. And then as we go into the future, we're going to migrate from a command line to a React app, so a web app. And then we'll add encryption, end-to-end encryption, and multi-user encryption. And then finally, we will add the messaging, which will demonstrate the real-time notification feature of the protocol. If anyone has any questions, feel free just to put them in the chat or jump on voice anytime. I'll make sure I'm monitoring the chat. Great. Okay. So let's have a quick overview of what Bubble Protocol is and what its ecosystem looks like. So for anyone who doesn't know, Bubble Protocol is an access control protocol for off-chain storage. So we already have off-chain storage in Web3. We've got IPFS. We've got other blockchain-based systems like Filecoin or Storage or Seer, Arweave. They all share the problem that once you've uploaded your data to them, it's now out of your control. You can't delete it. You can't update it. So you rely, if you want to put private data on a platform like that, you rely on encryption. Of course, you don't know how long your data is going to exist on the platform, and there is always the potential that encryption can be broken at some point in the future. So although these platforms are brilliant for many use cases, particularly for public data and NFT data and things like that, they're not that suitable for sensitive private data. So think, would you be happy uploading all your identity details to IPFS as an example? So what Bubble Protocol does as an access control layer, and by design, it doesn't specify the underlying storage platform. So you can apply this protocol to just a plain old home server, private server. You can apply it to a cloud service. You can apply it to your company infrastructure, your databases. and you can apply it to a decentralized storage network. And so part of the Bubble roadmap is to build a decentralized storage network like IPFS, but with access controls built in and a payment mechanism built in. So that's what we're hoping to do if we're able to fund ourselves and move forward. The protocol is EVM compatible, so it's not tied to a specific blockchain, but it supports EVM-based blockchains at the moment. And so in the ecosystem, in terms of the tools that we've developed, we have Bubble tools there on the left. That's the command line interface. That's kind of really useful for developers to play around with the protocol and maybe to do some maintenance or management of existing bubbles and data. Then we have the SDK on the right. The SDK has a client and a server part. The server part is for people to integrate the protocol into their storage systems. And the client part is what we'll be using throughout these workshops to build into our dApp. The client SDK is written in JavaScript, and it consists of various different classes and libraries. So for this workshop, we're going to use a subset of this ecosystem. We're going to use this is just for workshop 1. We're going to be using the Bubble Tools command line. We're going to be using the Bubble Private Cloud, which is a public cloud server. And that's run by us. And we're going to be using the Polygon blockchain. Going into workshop 2, we'll then introduce the client SDK and work through that. So the tools we're going to use today, we're going to use Remix to develop our smart contract and to deploy it to the Polygon chain. And we're going to use the Bubble tools. We're going to install and use the Bubble tools library to actually create the off-chain bubble and play around with the data. So again, just an overview. What is a bubble? For those who don't know, so a bubble consists of 2 parts, an on-chain half at the top and an off-chain half at the bottom. The on-chain half is a smart contract, and that specifies the structure of the off-chain content in terms of files and directories, and it specifies the permissions for each user for each file or directory in the bubble. The contract is used by the off-chain storage service to authenticate users of the bubble. And the contract must implement the bubble access control contract interface, which we'll go into later. The off-chain half, which in our case will be stored on the Bubble private cloud. That's just a cloud server with the Bubble protocol built in as acting a bit like a firewall. We call it the Guardian, and that protects the data, and it communicates with the contract to identify whether a request is permitted to access the bubble. So it stores the data in files and directories. It authenticates any requests based on the signature of the requester. And it only allows access to the bubble if the contract allows it. Now, every bubble has a globally unique identifier. That's derived from the chain ID of the blockchain that the smart contract is on. the address of the contract, which is of course unique, and it's the URI of the storage service on which the off-chain bubble is stored. So that might be if it's a cloud server, it might be just the URL of the cloud server. If it's a decentralized file system, it'll have some different form of URI. And so from that bubble ID, you can identify any bubble uniquely in the world. Now, each file and directory within the bubble has its own file ID, which is a 32-byte number. And so by adding the bubble ID and the file ID together, you can globally identify any file or directory in the world. So this is the access control storage interface. So this is a Solidity interface. It's very simple, and it's designed to be as flexible as possible. So all it requires, this function called get access permissions is called by the off-chain storage service whenever it receives a request to access data. And so the smart contract is in control of what permissions the storage provider must follow. So this function returns a 256-bit bit field. The most significant 16 bits are reserved for Bubble Protocol, and the rest you're free to use for your dApp's purposes. Currently, we have, 6 permission types. The first is a terminate bit. If that's set, then it means the bubble has been terminated and the off-chain storage system must delete the data. Then we have a directory, a read, write, and append and execute bits. So they're exactly the same as POSIX bits, apart from the append, which is a new one, which allows, which means you can only append to a file, you can't overwrite the file. So let's just quickly go into what's the point of having on-chain permissions and off-chain data? What's the benefit of it? So there are a number of benefits. One is that particularly for Web3, you are creating a direct link between your on-chain application logic and your off-chain data. So your on-chain logic can be changing the permissions based on its internal states, based on external oracles, based on NFTs, so who owns this NFT. And it acts as being on-chain. Of course, the properties of on-chain data is that the data is immutable, and it's public, it's transparent, and you've got an audit trail. So it acts as a service level agreement. It acts as a contract, a service level agreement contract between between users of this bubble. So for example, if we were a company and we have customer accounts and customer data, we can use an access control contract as a service level agreement that defines exactly who can access the data, when they can access it. It can change state based on interactions from suppliers or anything like that. And of course, the logic of the contract is transparent and auditable by everybody. So I think that's quite a powerful feature. Another aspect, there's a separation of concerns between the intelligence and the data storage. So the data storage half is is completely unintelligent. It just does what the access control contract says. So that makes it an ideal. It means that your off-chain storage services can be generic Dropbox-like storage systems. They can host any bubble for any application. And your on-chain access controls, of course, with all the benefits of being transparent and interactive, it's a perfect way to manage privacy and exposure of your data. You can also, of course, add things like payments to your contract. So a really simple example would be a contract that only allows someone access to read the contents of the bubble if they've paid a certain amount of money to the contract. So let's take this model and look at it in terms of what we're going to build today. So our on-chain logic, we're creating a shared vault here, shared file vault. So we want a structure inside the bubble that contains our shared files and our messages. We'll also add a global metadata file so that we can store things like the name of the vault, things like that. And we want to be able to add and remove members of our vault. If you're a member, we want you to be able to access. If you're not a member, we want you to not access. We also want to add a few query functions so that we can work out who is a member and who isn't, who's an administrator of the bubble, who isn't. And so we also need some sort of admin role in this contract. So in terms of permissions, the permissions we want to model in our smart contract here. So we're going to start, we have, every bubble has the special file 0, which is the root of the bubble. You can think of that as like a root directory of the bubble. If anyone who has write access to that has permission to create a bubble on an off-chain storage system. So our metadata file, we want our administrators to be able to read and write, and our members just to be able to read. Our shared file directory, let's make it so that everyone has full read-write access. So anyone can write a file, delete a file, update a file. Our messaging directory, we're going to make that so that people can't overwrite existing messages, but they can append new messages to the directory. So finally, this is the plan for today. The first thing we're going to do is create our smart contract, for which we'll use Remix. We're going to implement in that contract our application logic, which is all about adding, removing members. And we'll also add a terminate so that we can delete the vault as well. And we could put the bubble permissions in a different contract. We could have two contracts. But just to make it easier to deploy, we're going to put the bubble permissions inside the same contract, and we will implement the permissions that we just talked about. So that's step 1, create the contract. Step 2, we will then create our off-chain bubble, and we'll use bubble tools to do that. And we will read and write files, we will list directories, append messages, and finally we'll delete the bubble. So that's the plan for today. Any questions from anyone so far? Okay. So this is Remix. If anyone is anyone not familiar with Remix? If you're not, it's a tool that's been around since the early days of Ethereum, produced, I think, I'm guessing by the Ethereum team, as a way to create, compile, deploy smart contracts to Ethereum virtual machine-based blockchains. And it has some extra features like you can run unit tests and things like that, and debug and so on. So we're going to use this for today because it's a nice, simple contract. I wouldn't necessarily recommend it for larger contracts or multiple contracts, but it's pretty good for what we're doing. So let's start with our application logic. Let's start with our admin. We're going to have these admin controls. So let's use OpenZeppelin's access control off-the-shelf contract for that. Let's import that directly from GitHub. Oh, right. I'll have to restart Remix if that goes on. Okay, so that will bring that, and I need to restart Remix. Give me a second. So you can connect Remix to your local file system if you're running a daemon. This structure, by the way, is in GitHub. So I'll send you the link at the end of this session. So let's add a constructor. Now, something that's common in decentralized applications is to have a login process where you use your wallet to sign a login message, and that creates, essentially behind the scenes, that creates a unique private key, and then you can use that private key to interact with your application. So we're going to anticipate that for going forward, which will become clear later on. So let's give ourselves a login address as part of our constructor. And we need to grant admin access to whoever deployed the contract. So I'm going to use OpenZeppelin's access control function grant role. Let's see, it's admin role, and we'll give it. So the person who constructs this contract will have default admin role, and we will do the same for our login. Yeah. Now we're going to need to track our members. So let's add a members object. We'll create a mapping from address to bool, so that we can look up whether a member is a member or not, whether an address is a member or not. I'm going to also add our login as our as a member by default. Now we need to add some functions for we need to add some functions for creating and removing members. So let's do that as a single function where we'll pass an array of members and a Boolean to say whether we want them to be a member or not a member. And we're going to restrict access to this function to only users with an admin role. Again, this is part of the Open Zeppelin access control class. And so in that, we want to loop through all members, loop through all the given members. And add them and set the members flag for that user based on the value we passed. Is this 2 parameters. Let's create getter functions. Let's create one for admin and one for members. I'm just going to copy these. So our admin function returns an access control. It returns true if the user has the default admin role. IsMember returns true if the given user is a member of this vault. And finally, let's add our termination function. So we want a termination flag. Let's make it public so that we can read it and default it to false. And then let's add a terminate function. So here we go. If we're already terminated, we will revert with a message. And again, we're only going to allow admins to terminate the bubble. Now, I've taken the liberty of creating some tests for this. So I have the logic tests, which tests whether we can add members and remove members, and it checks the default status of the owner. So let's run these tests. Just the logic tests. Yeah, so all that looks good. So that's our dApp logic sorted out. Let's go on to what we're more interested in, which is the bubble itself and how we're going to run this bubble. So to do that, we need the access control interface. So that's part of the SDK. So if you go to the Bubble Protocol GitHub repo, we can look at the Bubble SDK, and there is a contracts directory in there. And then here we have our access control storage interface. And we'll make use of these access control bits, which I'll show you later. So access control storage, that has the function that we saw earlier. So we need to implement that. The access control bits, those are the locations in the bitmap that the access control storage needs to return, and we'll make use of these. Now, in this contract directory, we have these examples here. So one of the simplest bubbles here is a fully public bubble. In this case, it also allows the bubble to be terminated. And this It's about as simple as a bubble can be. So in this case, if it's terminated, we simply return the bubble terminated bit. If we're file 0, we only let the owner have access to file 0. And otherwise, everyone has read, write, and append. Similarly, this read-only bubble is very similar, but this just allows the owner has read-write access. Everybody else has public read access. But some of the more interesting bubbles are things like the ERC 721 contract. So ERC 721 is one of the NFT contracts. And so this bubble here links access to the bubble based on ownership of an NFT. So an existing NFT is passed in to the constructor, and only the owner of an NFT can access their content directory. So the bubble contains directories named after the NFT token ID. And so only the user who owns that token ID can access the directory with the same name. So that's a good way to have a sort of private NFT storage. This monetized bubble here, we mentioned this earlier. This allows people to send coins into this contract, and based on the number of coins, they get so many minutes of access to the bubble. So let's just copy this public bubble. Let's copy that as well, just to get us going. And we'll place that in here. Now, of course, we need to import our two contracts from the Bubble SDK. So we want to import this access control storage contract. And the access control bits. I think that's right. And we need to implement access control storage. So we don't need that because we don't have an owner field. And let's just return by default no permissions, just as a start. Okay. So let's run our tests for these permissions, and we'll do a little bit of test-driven development. So default access, let's have a quick look at the test file itself. So default access, by default, everyone has no access. Our root access, these come from our permissions that we defined earlier. So the root access, admin has read write, member has read access, and so on. So we would expect with our current implementation that our default permissions should pass, everything else should fail, except perhaps the terminated. We've got a terminated bit, of course. Where were we? So our default access passes, our terminated vault access passes, everything else failed. So let's now add our other permissions. So we want to restrict access to the bubble to members only. So let's add that as a condition. Members, not member. And then these are the permissions that we want. Let's add the root of the bubble. So we want to say if the requested content, which is the content ID parameter here, equals let's create our bubble structure as constants. So our root file is 0, metadata file we'll say is file 1, our shared file directory is file 2, and a messaging directory is ID 3. So if we're the root directory, we want to return based on whether the user is an admin as an administrator or not. So let's check if they are admin, then we want to return read write. So read bit and write bit. And if we're not an admin, we just want it to be read only. So that should be our root. Let's just run the tests. So check root access pass. Let's do our metadata file. Again, if content ID is actually the same, let's make that. Could make this more efficient if you wanted to. So that should be the same. Label metadata access passes. The shared directory, we don't need to check administrator. We want everyone to have read-write access, and it's a directory. So we need to add the directory bit. Let's check that. Check shared file. Admin should have. Need to change that, of course. Okay, check shared files directory passes. And now finally, we're going to do our messaging directory, which is similar, but instead of write, we're going to have append. Again, messaging directory. So there we have, that's passed. Let's run all the tests. Make sure they all still pass. And there we go. So that's our contract now finished. Let's now deploy this contract. Now we're going to deploy it to the, I'm going to deploy it using MetaMask. My MetaMask wallet is set to the Polygon chain, which is chain 137. So let's deploy this vault. So before we deploy it, we need to know what our login address will be. So to do that, we need to now install Bubble Tools. And let's create ourselves a key using Bubble Tools. So if we go back to GitHub, we need to go to the Bubble Tools repository and we'll install Bubble Tools from here. So in the README, we've got the installation process and setup process, which we're now going to follow. You may or may not need sudo rights to install. So we'll leave that to run. Once we've installed, we'll need to initialize our wallet by using the bubble command. It's time. So the Bubble Tools command line interface is effectively a wrapper for the Bubble client SDK. It uses the SDK to actually perform the functions. Just typing Bubble gives you the usage instructions. We have separate commands for accessing your wallet. There's an address book in there. There's an address book for Bubble providers. And the content command allows you to actually access and manage off-chain content. Contract commands allows you to interact with smart contract. We've used Remix today, but you could do everything that we've done in Remix in Bubble Tools, apart from compilation. And we've got some utility functions, which we might use a little bit later. So let's first create our private key. We're going to give it a label. We'll call it our VaultBox login key. So by default, as it says here, when you first create your key, you create a new key and it'll set it as your default key. You can have more than one key in your wallet, and you can flip between them by either setting one as default, or you can use the -K option. So now that we've done that, let's add our off-chain storage provider. In this case, it's the Bubble Private Cloud, which is at this URL. These URLs have the feature where you can add a variable in here. So this command, this particular URL will work with all sorts of different blockchains. So do that. And finally, we need some blockchain providers. So by default, the providers in GitHub don't have, you need some sort of gateway to the blockchain, whether that's Infura or some other provider, QuickNode or something like that. So you would need to add your own provider in there, but you can sort of piggyback on Bubble's Infura accounts as long as you're, as long as you don't abuse it. So we're gonna download these providers, and we'll store them in the Bubble Tools directory, which is held in your root directory, a hidden Bubble Tools directory. Okay, so let's just have a quick look at where we are. Let's list our wallet. We've got our VaultBox login wallet, VaultBox login. That's our address. We have our default key, which is set to the same, and there's an initial application key, which is set to the same. Let's have a look at our providers. So we have Bubble Cloud, we gave it the label bubble cloud, and that's the URL. So let's and now that we have our login key, we can create the contract. So let's copy that and go to Remix, and let's deploy an instance of this contract with our login key as this constructor parameter here. So that will request my wallet to deploy the contract to the Polygon chain. Give it a moment to be mined. And now here in Remix, we have the contract, and we can copy its address. And then let's add that. We can save that to our address book. So we go bubble addresses. If I just type a command, it'll list these subcommands within there. So you can see what commands you have. Also, if you use the -h or the --" help option for any subcommand, it will give you details about that command. So in this case, we're going to add, we need the label, the address, and then we can add some text if we want, optional text. Let's call it Vault. So this is our Vault contract. Give it the address. And now if we if we list, we'll see it there. So this means in other commands, we can just use the label rather than having to type in the address all the time. So, right, so now we have that contract. Let's just have a quick play with it in Remix. We can call some of these getter functions. So we can click on the terminated button, so it's not terminated. We can see if we're an administrator. So if I copy my wallet address, which is here, we can see, paste it in there. We can see that we are indeed an administrator. Now our wallet address should not be a member. So that comes out as false. So yeah, Remix is pretty useful for that. We can also do the same thing in Bubble Tools. Sorry, Bubble Bubble Contract. We have these different subcommands deploy. We can call getter functions. We can transact with other functions, and we can get permissions. So let's get permissions. Contract permissions, and we need the contract address, which we can just use on a label. And we need a user and a file. So let's add our Vaultbox login. We can use labels again, or you can paste the address in there. Vaultbox login as a user, and let's use the root file 0, and that shows us what access permissions we have. Similarly, if we look at the messaging directory, we have a directory, and we have read and append. And if we try a directory we don't control, then we have no permissions at all. Right, so let's now create the off-chain bubble. So we have our contract, We now need to create the off-chain part of the bubble. So we'll do bubble content, and we'll see we've got this create bubble command. Create bubble, we need to provide the provider, which is the bubble cloud, again using our label that we set up earlier. And the contract is our vault. And our default key is already set to our vault login key, so we should have access rights to create the bubble. So that's now created. Let's list the root directory. So we want to list bubble cloud, the vault contract, and file 0. Let's just see something out there. Let's see, bubble command. Oh, I missed out content. Bubble content list. So that's empty. So let's write our metadata file. Let's bubble content write. Again, bubble cloud vault file 1 this time, and we're going to give it some data to write, and we'll give it JSON. Let's make it a JSON file. So we want just give it the name and call it workshop 1 shared vault, something like that. So now if we read that file, it returns the contents of that file. Let's create the directory for our file directory. So that's mkdir bubble cloud vault, and that's directory 2. And then if we go back and list the root directory, we now see we have file 1, that's its full 32-byte file ID. That's a type file. And we have our our file directory, ID 2, and that's a directory. And let's try writing a file. We know that we have append but not write access to the messaging directory. So let's try writing file to the messaging directory. Directory 3. And if we put a /, we can then specify a subfile within that directory. Now, directories in a bubble, the directory structure is a flat directory structure. You can have files and directories, but you can't nest directories. There's no real point in doing that. You can do that at the application side if you want to. But the content of a directory takes its permissions from the permissions of the directory itself. So the name of a file within a directory doesn't matter. It can be anything you like. So let's just call it A. And give it some data. Hello world. Just start quote. Why have I done that? What have I done there? What am I missing? Let's try that. Right. So because we tried to write to a directory we only have append permissions for, it's telling us we don't have permission to do that. So if now we change that to append, that was successful. And now we can read that back. And there we have it. Again, if we now list our root directory, you'll see that the messaging directory was automatically created when we appended a file into it. So that's basic creating a bubble, reading, writing. Now let's add our friends into let's share these files with our friends. So let's create where are we? New window. Let's create Alice and Bob. Let's change the prompt so that we can see what we're doing. And let's create Bob's in the same way. So we now have Alice and Bob. So we need to create keys for them. So normally, of course, they would be on their own PCs, but we're using the same bubble tools file. So we need to create keys for each one. So let's do bubble wallet create, give it a label. Let's call it Alice in this case. There's Alice's address. And let's do the same thing for Bob. And that's Bob's address. Now, of course, Alice and Bob aren't yet members of our vault, so they shouldn't be able to read from the bubble. So let's just try bubble content read. Again, bubble cloud vault. Let's try the root directory. Of course, the default key is this owner login key. So we need to specify the key here that we're actually executing this command as Alice. Permission denied. That's what we'd expect. Let's try the same thing for Bob. Permission denied. Now let's add both Alice and Bob to our smart contract. So if we go to our set members function, and we will pass in an array containing Alice's key and Bob's key. And we'll set membership to true. This is a blockchain transaction, so it needs to go through the wallet. Wait for it to be mined. Okay. So now let's try and read that now as Alice. Oh, interesting. Why has that happened? More content. Why is that not happening? File 1. Interesting. Not sure I understand why that's happened. Let's try with Bob. Same again, interesting. Okay, so for some reason, Alice and Bob can't access the root directory. Oh, that's because I'm trying to read it. You need to list the root directory. List. There we go. Root directory is a special file. Okay, so Alice and Bob now that we've added them to the contract, now they have access to the bubble. So let's send a message between Alice and Bob. So content append. So it's directory 3. Let's call this file B, give it some data. Hi, Bob. And let's read that, shall we? B. Hi, Bob. So now let's remove Bob from the contract. So we're going to set members. This time we're just going to have an array with just Bob's key in it. And we're going to set members to false. Transact. Again, wait for the transaction to be mined. There we go. And let's try Bob can read that. Try and read that again. Oh. What we did miss out, of course, was calling that function as Bob. Without the minus key, it was calling it as this member on the right, the owner. So Bob no longer has access. Let's try Alice. Alice still does have access. Let's go back up to that one. So Bob doesn't have access anymore. So we've demonstrated we can add and remove members, and that when we do that, and in our smart contract, the permissions for the off-chain bubble are instantly changed. One last thing, let's delete the bubble. So we'll do that by terminating our smart contract. So we hit the terminate function. Again, send the transaction. Wait for it to be mined. We can check the terminated accessor function now returns true. And so if Alice tries to now list the bubble, you'll find that it's been terminated. Bob the same. So now the bubble itself has been terminated, and the bubble actually has been deleted off the off-chain server. No, data no longer exists. So that's now the end of this workshop. So let's just quickly summarize what we've done. We created a smart contract on the Polygon blockchain using Remix. We added our member logic to that contract so we could add and remove members. And we added the access control storage interface to our contract to allow it to control an off-chain bubble based on our membership. We then created the off-chain bubble, and we had a play around reading and writing. We added Alice and Bob as members to the bubble and showed how they could now access the bubble. And when we removed Bob's membership from the contract, Bob lost his access to the off-chain bubble. And by doing that, we got to experience some of the Bubble Tools command line interface. So that's it for workshop 1. Does anyone have any questions or would like to look at demoing anything else while we're here? Give it a moment. Well, okay, if there aren't any questions, I will just stop the recording